Hello friends, this video on relations and functions part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. As to symmetric and reflexive, let's try to understand the third complex type of relation, that is transitive relation. As a word transitive means you move from one place to another place. You start from A, you move to this place, and then you reach C. That is the meaning of transitive, something that moves on. So there are three, I can say, poles or place. There's a guy name is Rohit. This guy moves from A to B, and then he moves from B to C. So finally what we have seen, Rohit has moved from this point to this point, correct? So he moved from A to B and then B to C. That is the meaning of transitive. If you have this in your mind, then you can understand transitive relation in a better way. Transitive means the person moves from A to B and then B to C. So in mathematical world, if you see, a relation is called transitive if A1, A2. Let's suppose if A1 comma A2 is part of the set, correct? Also, if A2 comma A3 is part of the set, that should imply that A1 and A3 is also part of the set. This is the game of transitive. Please know, in case of transitive, if a relation is said to be transitive if and only if you find that A1, A2 is part of set, also A2, A3 is part of set, the relation set, the R, bigger R set. In that case, A1, A3 has to be part of the set. If that is true, then only that particular relation is called transitive relation. Right? See, to get a relation, for example, if you're getting a relation on A only, you take all the objects of A and you say A cross A, you get some items. From these items, based on relation, greater than, equal to, height is more, height is less, some pattern, based on some pattern, you get a subset. So from this you get a subset and you get this relation. In this relation, if you see if A1, A2 is there and A2, A3 is there, and also A1, A3 is there, then that relation is called transitive relation. If both these are there and this is not there, then this is not transitive relation. I'll explain with some example. So if I say height of boys, I'll take the same example, simple example. So let the height of boys be A1, A2, and A3. Now I'll say height of A1 is equal to height of A2, that is one set. Height of A2 is equal to height of A3. This implies height of A1 is equal to height. For example, if you take three boys here, I'll name them. This guy is A1, this guy is A2, this guy is A3, and this guy is A4. So if I say that height of or equal height, A1 is equal to A2, this is one thing I told. Then I told A2 is equal to A3, this is the second thing I told. With this, I imply that A1 is equal to A3. Height of A1 is equal to A3. If such kind of relation exists, then this kind of relation is called transitive relation. So in case of equal to relation, this is the transitive relation. When I am saying height of A1 is equal to A2 and A2 is equal to A3, then that implies height of A1 is also equal to A3. Correct? So in this case, if you see what we have done, height of A1 is equal to A2, that was there, and height of A2 is equal to A3, also there. With this, we have seen that height of A1 is equal to A3 is also true because all are equal heights. So all these three objects are there in part of this relation. So this kind of relation is called transitive relation. I'll give an example of non-transitive relation to make doubt clear. For example, I say height of A1 is not equal to height of A2. Not equal to is my relation here. In earlier case it was equal to relation. Now I am taking about not equal to relation. So in that case, if I am saying that height of A1, let's suppose the height of this guy is 4 centimeter, this guy is 5, and this guy is 3. Now, or let's suppose this is 4 only actually. This is 4. I'll tell you why I didn't take 3. Now, when I say that height of A is not equal to A1 is not equal to 2, it means 4, 5 will form a pair. So 4, 5 will form a pair. Similarly, height of A2 is not equal to A3, this guy will also form a pair because the height are not equal. So 5, 4 will also form a pair. This should imply that 4, 4 should also be the part of relation. But 4, 4 means the height of this is not equal to height of this, but they are equal. So this is not part of the set. The only element in this set is this and this. So this is example of non-transitive. Why I took 4 was this? Because if we take 3, this becomes a transitive. But even if there is one element, there is one element which can make this whole set non-transitive, then this will be called non-transitive. So generally not equal to is called non-transitive, because there may be a case where this guy's height is same. If you are given the exact heights, then by looking at data you can say where the set is transitive and non-transitive. If the exact height is not mentioned, please mention not equal to relation as non-transitive also. Also, the greater than relation is also non-transitive. I'll tell you examples, tell you why. So let's suppose let's give the name here. I'll say B1, B2, B3 and B4. Be the names of all these 4 boys. So this is example of less than. B1 height is less than B2, correct? Similarly, B2 height is less than B3. This implies B1 height is less than B3. This will be true for all the cases. So here you see less than is a transitive relation. So less than, I'll say less than, greater than are generally transitive relation only. Not equal to are generally non-transitive relation. Equal to is also transitive, because you flow from here B1 is less than B2, B2 is less than B3. This implies B1 is less than B3. That means if relation exists between this and this, if the same relation exists between this and this, then there has to be same relation between this and this. If that exists, then it is called transitive. If you see here, the relation is flowing from here to here. From here to here it went, from here to here it went. That means there is a relation from here to here. And I am saying that boy moves from A to B, then B to B, C. That means I am saying boy moved from A to C. Similarly, relation between B1 and B2, B2 and B3 implies relation between B1 and B3. So that is what we call transitive relation. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.